Okay. All right, so what we want to do is pick random x values. Let's say 0, 1, -2. So just pick any values of x, and then we're going to plug them in and solve for y. So what I usually do is make a little table for my work, and then let's do this. So y equals the absolute value of 0 plus 4. Well, 0 plus 4 is 4. So we have the absolute value of 4, and the absolute value of 4 is 4. So that gives us one ordered pair. Now let's do the second one. So we're going to replace 1 for x here. So y equals the absolute value of 1 plus 4, which is the absolute value of 5, and the absolute value of 5 is 5. So that gives us another ordered pair. Now at -2, y equals the absolute value of -2 plus 4. -2 plus 4 is 2, and the absolute value of 2 is 2. So once we have 3 points, we're going to go ahead and graph and see if that's enough points to see our V. So 0, 4, 1, 5, -2, 2. That doesn't look like a V, does it? It looks like a line. So that tells us that we need to pick some more points until we see where that V happens. So let me bring this down, and it looks to me like it's coming this way, and it's going to V over here somewhere. So let's see what happens when x is -3. So when x is -3, scoot it up a little bit, we're going to plug -3 in. So I have y equals -3 plus 4. So y equals the absolute value of 1, and the absolute value of 1 is 1. So -3, 1, so we don't have it yet. So let's keep going. Let's see what happens at -4. So -4, y equals -4 plus 4. -4 plus 4 is 0, and the absolute value of 0 is 0. That gives us another point. We still don't have the V. We have it coming all the way down. I bet it's going to turn here. So let's see what happens at -5. I've got to continue my list over here. So at -5, I have y equals the absolute value of -5 plus 4. -5 plus 4 is -1, and the absolute value of -1 is 1. So finally, there we have it. So now we can say with some confidence that our graph would look like this. Now, I'm pretty sure on the final, this question may be one of the multiple choice, but again, if you can show me work of how you find the points, you can still earn partial credit even if you happen to pick the wrong graph. All right, so again, we talked about different kinds of graphs. Remember, if it's something squared, it gives us a U shape. So for instance, if you're going to graph y equals x squared, we know that would be a U shape. So those were the two main shapes. We also talked about lines, but as far as the final goes, what you'll be asked to do with the linear functions is find the intercepts. So let's go ahead and review that. So let's find the x and y intercepts. Of 4x plus 3y equals 12. Okay, so to find the x-intercept, remember that's where the line crosses the x-axis. At the x-intercept, we know y equals 0. So I'm just going to write this equation and replace the y with 0. All right, so I have 4x plus 3 times 0 equals 12. 3 times 0 is 0, so we can disregard that, and I have 4x equals 12. Divide both sides by 4, and so I have x equals 3. So my intercept point then is 3, 0. When x is 3, y is 0. So intercept. To find the y-intercept, we let x equal 0. So I have 4 times 0 plus 3y equals 12. So 4 times 0 is 0. We can disregard that. So I have 3y equals 12. Divide both sides by 3, and I get y equals 4. So the ordered pair then is x is 0, y is 4, and that is my y-intercept. All right, so that was the end of that test. I believe all that was on one test. The next thing we talked about was factoring, and factoring seems like it lasted forever, right? So let's start with this example. So if we're asked to factor this completely, the first thing you want to look for is, do they all have something in common? Do they all have something in common? And the answer to that is no. There is no GCF, no common factor. So the next thing we do is recognize that we learn to factor by grouping, where you group them into pairs. So in this pair, I can factor out a 2b, and that leaves 2b minus c. 2 times 2 is 4, b times b is b squared, 2b times c is 2bc. Bring down the sign, and then these have in common a 7 and a d. So when I factor that out, that leaves c, and then negative 7 times negative 2b. So now when we look at this, is what's inside in common? And the answer is no. I pulled a final from a couple of semesters ago to use as our review. And what I see happens here is this one is actually more complicated than you'll have or that we talked about. Because what is the difference here? These two are not the same, right? So as it is, we couldn't go any further. So what you have to do is recognize that this is the opposite of this. But I tell you what, instead of worrying about fixing that one right now, let's just do an alternative one, because I don't want to spend your time on something that won't be on the final. So sorry this happened live, but that's how things go sometimes. So let me just do that one over in a way that will be more helpful to you as far as the final. All right, so let's let me go ahead and do this next type, and we'll come back to one like that. All right, so let's focus on this one while I look up an example to give you of the grouping. So for here, if the directions say factor, the first thing we want to do is find the GCF. So make sure that you do that first always. So in this case, what we can factor out would be a 2. And if I have x cubed, x squared, and x, remember you always take the smallest exponents. You're going to factor out an x. Open the parentheses, and then we're going to multiply back through. I'm still looking up a factoring problem here. Okay, so 2 times 2 is 4. X times x squared will give us x cubed. 2 times negative 7 will give us 14. And x times x would give us x squared. And then lastly, 2 times negative 15 would give us 30. And then we don't multiply by x because we already have an x here, so we just close the parentheses. Now we need to see if we can factor this trinomial further. So the way we do that is we multiply the 2 times the 15, and then list the factor pairs of 30. So that's 1 and 30, 2 and 15, 3 and 10, 5 and 6. That should be a comma. And let's see, is that all? I think that's it. So we need the pair that combines to give us 7, and that would be 10 and 3. To be a negative 7, it would need to be a negative 10 and a positive 3. So remember, we're going to rewrite this by rewriting the middle term. So I have 2x squared plus 3x minus 10x minus 15. And then factor each pair. So this pair, so here's a grouping problem for us. We need to factor this pair and this pair. So here I can factor out an x, and that leaves 2x plus 3. Oh look, just like in class, my pen is dying. Memories. Okay, let me go find a pen, and y'all finish working on this one. I have a new appreciation for all those YouTubers that tape lectures and things. It's a lot harder than it looks. Okay, so x times 2x plus 3, bring down the sign, and then here I can factor out a 5, and negative 5 times 2x gives me 10x, and negative 5 times positive 3 gives me negative 15. So you will have problems that work out like this, not like the one that I had to kick out a minute ago. So now look at these, and what do they have in common? 2x plus 3. So factor that out, and what's left is x minus 5. But don't forget, after all that extra commotion, that you bring down the original factor that you pulled out. So all three of these multiplied together would be the factorization that we were looking for. So factored by grouping, factored by trinomials. I want to show you one like that. Also, we learned to factor binomials. So for instance, if I have 4x squared minus, let's see, 36. Now that is the difference of squares, but even before you do that, remember we always want to look for the GCF. So what will go into both of these? 4. So I'm going to factor out a 4, and that leaves x squared minus 9. Now, x squared minus 9 is the difference of squares. So hopefully you recognize that means this factors as x plus 3 times x minus 3, and then we bring down that 4. So that would be the complete answer. I'm not going to, or there are not difference or sum of cubes on the final. Remember, that was that longer formula. I don't think I put that on the test either. So you only are responsible for knowing how to factor this one, the difference of squares. So in that factoring chapter, The last thing we did, which we've done a lot since then, is solve by factoring. So this would say solve. So just pay attention to the directions. If it says solve, that means your answer is going to be x equals something. You're going to have an actual solution. You're not just factoring. Now on the final, it will go further though. It will tell you how to solve. So it will say solve by factoring. Because if you have done the last two sections, you know we've learned two other methods now for solving quadratics. And this is a quadratic. We know that because x is squared. So the first thing we're going to need to do is set it equal to 0. So we're going to subtract 15 from both sides. And then we're going to factor. So this looks very similar to the one we just did. Funny how that works out sometimes. So we take the leading coefficient and the constant and we multiply those together. So we get 30. So we just listed all those pairs. 1 and 30, 2 and 15, 3 and 10, 5 and 6. And this time, to get a coefficient of 1, it's going to be this pair. And to get a -1, we need a -6 and a +5. So we're going to rewrite this term as positive 5x minus 6x. But the difference is you have to make sure and keep writing equals 0 because we're dealing with an equation now. So we're going to factor by grouping. So here we can factor in x, and that leaves 2x plus 5. Bring down the sign, and then here I can factor out a 3. So -3 times 2x is -6x, and -3 times +5 is -5. But there's one more step to factor. We have this term minus this term. Now I need to factor out the 2x plus 5, and that leaves x minus 3. All right, so this is where we say if a times b equals 0, then either a equals 0 or b equals 0. And we want to solve both of those. This one's easy. That's just x equals 3. For this one, there's a few more steps. I need to subtract 5 from both sides and divide both sides by 2. So x equals -5/2. So that would be our other answer. So again, on the final, follow the directions. If it says solve by factoring, I'm going to be looking for you factoring it because this could actually be solved by the quadratic formula also. So again, fax me your work afterwards, not fax. You can scan it. There's an app that lets you use your camera to change things to a PDF. That's a free app you can get on your phone, or if you have some other way, that's fine. Or if you just need to take a picture of it, you can. All right, so that was the conclusion of the factoring chapter. The next thing we looked at was rational expressions, which is when you have algebraic fractions. So find a good one to start with. So let's simplify x squared minus 5x plus 4 over x squared minus 4x. So to simplify a fraction, you simplify the top, simplify the bottom, and then eliminate any common factors. So factor the top. I said simplify, but we're going to factor the top, factor the bottom. So factoring the top gives us x minus 4 times x minus 1. The denominator, we can factor in x out, so that's x times x minus 4. And then eliminate common factors, which would be the x minus 4s, and that leaves x minus 1 over x. So that would be the simplified fraction. Now, there's one other piece that we did in the same section. We learned how to simplify. We also talked about how to tell what value is not included in the domain. So let's say given f of x equals x plus 1 over x minus 5, what value of x, excuse me, so remember domain, domain means the values of x that can work. In this case, there's one value of x that would cause a problem here. Remember, denominator cannot equal 0. Denominator cannot equal 0. So what you're thinking of is what value of x would make the denominator 0 here? And that would be 5. If x is 5, 5 minus 5 is 0. So we would have to say then that x cannot equal 5. And we talked about that later on in this chapter when we looked at solving equations, and we'll get to that in a minute as well. But if you recall, we had some problems in that section where they just ask you to do this, just state what value x could not be that would make the denominator equal to 0. All right, so we simplified, then we multiplied and divided. So let's look at a multiplication problem. Now remember, the only difference between multiplying and dividing is when you divide, you change it to multiplication and flip the second fraction. So if you're given a division problem, down the first fraction just like it is, change it to a multiplication, and then flip the second fraction over. So now we're going to factor both numerators, both denominators. So factoring this numerator, I get m minus 4, m plus 2. Here, what do they have in common? 8. And that leaves m plus 3. Here we would factor and we get m plus 4, m plus 3. And here I can factor out of 2, and that leaves m minus 4. And cross that out. So now to multiply, we're going to have a new fraction where we multiply all the factors across the top and all the factors across the bottom. So the new fraction will have m minus 4, m plus 2, m plus 4, m plus 3, and then in the denominator, 8. Remember, we put the shorter ones in front, so that's an 8 times 2, and then m plus 3, m minus 4. So we factor all the tops and bottoms, multiply top times top, bottom times bottom, and then eliminate all the common factors from the top and bottom. So the m minus 4s go, the m plus 3s go. So the answer is what's left, m plus 2, m plus 4 over 8 times 2, which is 16. So that's going to be our final answer. All right, we also added and subtracted these fractions. So if I have 2 over x squared minus 4x plus 4 plus 3 over x squared minus 2x. All right, so the first thing to do is to find the LCD. Remember, to add or subtract fractions, we have to have a common denominator. So to find the common denominator, we start by factoring. So factoring here, I get x minus 2 times x minus 2. Here, if I factor out an x, that leaves x minus 2. So our LCD has to contain every factor from every denominator. So we need x minus 2 again, and then an x, and then we see another x minus 2. So you have to think about the rule. You only repeat a factor if it's repeated in a single denominator. So that's why I knew to list it twice. But I don't need it 3 times because here it just appears once. So you repeat a factor as many times as it appears in a single denominator. All right, so now we're going to set up what we need to find our equivalent fractions that have that denominator. So now we're going to say, okay, what do I need to multiply by this denominator that will create this denominator? In other words, what factor is missing? And it's that factor of x, isn't it? So we're going to multiply top and bottom by x. So 2 times x is 2x. And then to go from here to here, what we're missing is that extra factor of x minus 2, top and bottom. So we're going to show 3 times x minus 2. So now we have our equivalent fractions, and I need to add those. So what we do is we add the numerators to create our new solution fraction, add the numerators, and the denominator stays the same. So I have 2x plus 3 times x minus 2 over that denominator. And then we're going to multiply here. So that's 2x plus 3x minus 6 over. And then finally, combine your like terms. So 2x plus 3x is 5x minus 6. Now, can I factor this numerator? No. And if I can factor it, it can't be simplified. So this is our answer, just like that. So we simplified rational expressions, which are algebraic fractions. We multiplied and divided. We added and subtracted. And the last thing that we did with them is solve equations that involve those algebraic fractions. So an example. All right. So to solve algebraic equations, the first thing you need to do is identify the restrictions. The restrictions are the values that would make the denominator 0. So in this case, that would be -2. So we say x cannot equal -2. -2 plus 2 is 0. Division by 0 is undefined. So we have to make that restriction that x cannot be -2. Next, we're going to multiply by the LCD. So the LCD has to have a factor of x plus 2. That's the only one, right? X is not in the denominator. So the only denominator is x plus 2. So it just has that one factor. So I'm going to multiply every term by x plus 2. So when I multiply by the x plus 2 here and divide by x plus 2, those cancel, leaving x. Here there's nothing to cancel, so we're just multiplying. And here, those cancel, leaving 5x plus 8. So now we have an equation without fractions. So we need to multiply. Using the distributor property, I get x squared plus 2x equals 5x plus 8. Combine your like terms over here. So that's x squared plus 2x plus 1x is 3x. Now, what kind of equation is this? Well, you need to notice because x is squared, that means it's a quadratic equation. And the general way we solve quadratic equations is by setting it equal to 0 and then factoring. So I'm going to subtract 5x from both sides. So that cancels. And then I also need to subtract 8 from both sides. So x squared minus 2x minus 8 equals 0. And then solve by factoring. So this would be x minus 4, x plus 2 equals 0. So this is my a times b equals 0. So either a equals 0 or b equals 0. So here I get x equals 4. Here I get x equals negative 2. So I've gone off my page here, but remember that you need to compare to the restricted value. And our restriction was x cannot be negative 2. So what we have to do is throw that answer out, and this is the only solution then. So remember, whenever you're dealing with a fraction with a variable in the denominator, you have to make sure that that denominator does not equal 0. All right, so that was the end of test 3. The next thing we looked at was a section on radicals, square roots in particular. Okay, so here's an example. We'd be asked to simplify. So we're going to think about the numerical part first. So I'm going to come off to the side. And remember, we're looking for the biggest perfect square factor. And the perfect square factors are 4, 9, 16, 25, etc. So 4 does go into 40, and there's nothing bigger that goes in evenly. So 4 is the one we're going to use. So we rewrite this as the square root of 4 times the square root of 10. And the square root of 4 is 2. So the square root of 40 is 2 times the square root of 10. So I'm going to come up here and replace the square root of 40 with what we found here. So the 2 comes out, r squared stays where it is. I'm going to leave a little bit of room and then put my square root with a 10 under there. So I'm leaving room because now I have to evaluate the variable part of this. So the square root of r to the 4th, you take the understood 2, that means square root, and you divide it. So 2 goes into 4 2 times. So that's r squared. And 2 goes into 12 6 times. So that's s to the 6th. So we're going to clean this up now. What is r squared times r squared? r to the 4th, s to the 6th, the square root of 10. So that would be the answer. Real quick though, let's just refresh your memory on what happens in a case like this. So let's say, whole different problem here. If I want to simplify the square root of x to the 7th, you say 2 goes into 7 3 times, so x to the 3rd comes out. But 3 times 2 is 6, not 7. There's one remainder. So the remainder of 1 stays underneath the radical. Now 2 goes into 13 6 times, so that's y to the 6th. 6 times 2 is 12. There's 1 left over. The leftover is left under the radical. So basically, whenever you're taking the square root of an odd number, you're going to have 1 power of that variable or variables left underneath. For this example, they were all even, so we didn't have to worry about that. All right. So we simplified radicals. We also added and subtracted. And what we found out is that to add and subtract radical terms, they have to be like terms, which means the radical part has to be exactly the same. So when we look at these right now, we can't add and subtract them. So what we want to do is simplify each one first. So simplifying this, can the square root of 3 be simplified? No, so that stays square root of 3. So we know I'm going to have the square root of 3 in my answer. But the square root of x squared is x, so that comes out. All right, so going on to this one, can the square root of 27 be simplified? Yes. Let's see what that looks like. The square root of 9 times the square root of 3. Square root of 9 times the square root of 3. So I know, again, I'm going to have the square root of 3 in my answer. But what is the square root of 9? 3. So that's going to come out and multiply by this one. So I'm going to have a minus 3 times 3. This x is already out here. Now, what about the square root of x squared? What's the square root of x squared? Just x, right? So another x is going to come out, and we don't have any remainder. So let's clean this up now. 3 times 3 is 9. X times x is x squared, and then we have our square root of 3. Just rewrite this one. And then finally, we have this one. So we just simplified the square root of 27. We know that that's the square root of 9 times the square root of 3. And we know the square root of 9 is 3. So 3 is out times the 7. We know the square root of 3 is going to stay underneath. And the square root of x to the 4th. Well, 2 goes into 4 2 times. So x squared comes out. And then 7 times 3 is 21. X squared, square root of 3. All right, so are these all like terms? Well, yes and no. They all have the same radical part, but I can't combine an x with an x squared. So I'm going to combine these two, negative 9 plus 21. So that gives us 12x squared, square root of 3. And then this just goes in front of it, like so. So again, the square roots of 3 make them like terms, but you also have to take into consideration the coefficients, and those cannot be combined. So that would be as much as you could do there. So to add and subtract, remember that you simplify each of them and then combine if you can, if they're like terms. And they won't always be like terms. So after adding and subtracting, next we looked at multiplying. And the product property tells us when you multiply a square root times a square root, you get a square root. So this is going to be 5 times the square root of 3 times 6, which is 18. X squared times x is x to the 3rd. So you multiply first, and now simplify. So don't be tempted to simplify here. You want to multiply first, then simplify. That will keep you from getting into trouble. So the square root of 18 is the square root of 9 times the square root of 2. The square root of 9 is 3. So that's 3 times the square root of 2. So I'm going to replace the square root of 18 with this quantity. So that 3 goes in as multiplication, leave some room, and then I still have a 2 under the radical. So that's how we deal with the square root of 18. But now the square root of x cubed, we say 2 goes into 3 one time, so 1x comes out, but there's 1x left over, so that stays inside. And so finally, 5 times 3, that's 15x, and the square root of 2x. So that's our answer. So to multiply, just multiply underneath the square root, and simplify if you can. Just a quick reminder, we also looked at examples like this, where if you were asked to square a binomial, that means you need to multiply it by itself and FOIL it out. So the square root of 3 times the square root of 3 is the square root of 9, which is just 3. On the outer, I have x square root of 3. On the inner, I also have x square root of 3. And the last times the last is x squared. Now, I can combine my like terms there, and that gives us 2x square root of 3. So that's going to be our answer. All right, so simplify, add and subtract, multiply. The next topic was dividing, but we had a different name for it. And that was rationalizing. So to rationalize the denominator, if there's one term on the bottom, you multiply top and bottom by that radical. Reason being that whenever you multiply a square root by itself, it has the effect of removing that radical, because this would give us the square root of a squared, which is just a. So a on the denominator, and then you just multiply the numerator together, and that would be our answer. So again, the key here is that when you multiply a square root by itself, you eliminate the radical, and that is our goal with these problems. All right, now the other type we looked at is when we have two terms in the denominator. When there's two terms, you multiply by the conjugate. And remember, conjugate means you use the same terms, but you change just the middle sign. So we multiply top and bottom by the conjugate of the denominator. So when you FOIL this, 3 times 3 is 9. On the outer, I get -3 square root of 7. On the inner, I get +3 square root of 7. And then the last times the last is a negative, and the square root of 7 times the square root of 7 is just 7. These cancel, and that's why we multiply by the conjugate, because we know that's going to happen. And then 9 minus 7 gives us a 2 in the denominator. So for the numerator, you just bring it across as multiplication, and you can stop there. Now, if this had been a 6, we could have simplified that, factored it out, but as it is, that's going to be all we can do. All right, and the last problem in that section that we talked about was solving equations that involve radicals. All right, so directions will just say solve here. And the only thing we need to remember, well, there was a couple things. First of all, we learned that we can square both sides in order to solve this as long as we check the answer. So you must check the solution. So if I have 4x plus 9, I'm going to square that side, square this side. Now when you square a square root, it removes the radical. 5 squared is 25. And now solve for x. So I'm going to subtract 9 from both sides. So I have 4x equals 16. Divide by 4. So x equals 4. So far so good, but we have to check it and be sure that it works. So I have the square root of 4 times 4 plus 9 equals 5. So that's the square root of 16 plus 9, which is 25. And the square root of 25 is 5, so that works. But you'll recall in that section, sometimes you would get an answer that did not check, and that was what we called extraneous. So watch out for extraneous solutions. But as long as your answer plugs in and checks, you're good, and you know that one works. All right, so that completed tests 1 through 4, and then we did 2 topics, which I said 1 each will be on the final. So the first one was solve using the square root property. So the directions will say solve using this property, and since you are submitting your work, I'll be able to check that you actually use that property, so be sure that you do so. So the square root property is the one that said if a squared equals b, then a equals plus or minus the square root of b. So you need to know this. So this matches this step. We're just going to write this step down. So we take out of the squaring and we take plus or minus the square root of the right-hand side. So this is my if statement and this is my then statement. So let's go ahead and simplify this. So the square root of 20 would be the square root of 4 times the square root of 5. And the square root of 4 is 2. So that's 2 times the square root of 5. So 2y minus 3 equals plus or minus 2 square root of 5. All right, now I need to solve for y. So I need to get this term by itself. So I'll add 3 to both sides. Now remember, this part was a little awkward at first, but you have to put that 3 in front. So it's a positive 3, which is assumed, so I don't have to show it's a plus 3. We know it's a plus 3. Put it in front of the plus or minus, and now divide both sides by 2. So y equals 3 plus or minus 2 square root of 5, all divided by 2. Now, don't be tempted to cross these 2's out, because it's this entire numerator divided by 2. And if 2 won't go into both pieces, then you don't divide it into either one. You just leave it alone. And remember, in my math lab, which is where you're taking the final, you can't enter the plus or minus together. You would have to list 2 separate answers. So you would do use the fraction template and say 3 plus 2 square root of 5 over 2 and 3 minus 2 square root of 5 over 2. So be sure that you remember that. So that was the square root property. The very last type of problem then would be one like this, and it would say solve using quadratic formula. So this is what we talked about on Monday. And you do need to memorize this formula. And here it is. X equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. First thing we have to do is set it equal to 0. So I'm going to subtract 5x from both sides and add 7 to both sides. So I have 2x squared minus 5x plus 7 equals 0. And we need to identify a, b, and c. Well, a is the coefficient of the squared term. B is the coefficient of the x to the first term. And c is the constant. So we're going to take these values, plug it into this equation. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And then we're going to carefully simplify. The opposite of negative 5 is 5. Negative 5 squared is 25. Complete this multiplication and then write the answer here. So negative 4 times 2 is negative 8. Negative 8 times 7 is negative 56. So that's what we write down. 2 times 2 is 4. And x equals 5 plus or minus the square root of negative 31 over 4. All right, so now, a lot of work, feels like we should be done, but we need to see if this can be simplified. First thing you need to notice is that this is imaginary. This is an imaginary number. We know that because it's the square root of a negative. So remember, the way we simplify that is we take out the square root of negative 1. That's what makes it imaginary. So the square root of 31 cannot be simplified, but the square root of negative 1 is I, and we write that in front like so. So we have x equals 5 plus or minus I square root of 31 all divided by 4. So those are our two solutions. Now let me just refresh your memory of how we deal with those imaginary numbers with ones that simplify a little bit more. So this, let's say you were solving and you got x equals plus or minus the square root of negative 24. So what I wanted to do is just practice simplifying this radical. So the square root of negative 4, you would rewrite that as the square root of 24 times the square root of negative 1. So the square root of negative 1 is I, but the square root of 24 can also be broken down, right, as the square root of 4 times the square root of 6. And the square root of 4 is 2. So we've got all these things clumped together. The way you write them is you put the number first, and then I, and then the radical is always last. So that would be what we end up with there. All right. That concludes the material that you need for the